Kenny and your favorite Jersey guy, Tom. Get ready for another round of our real talk, crazy stories, and everything in between.
Yes.
Let's do it.
What it be like, fellas?
Not much. What's going on, brother?
Nothing. How you guys doing? Everything good?
I'm great.
Yeah.
Great. Yeah.
Thirsty
Drinking my
over there.
energy drink.
Yes.
So I have some energy.
I need some energy. All right, Luke. Talk to us.
We're gonna do. We mentioned it in the last
2 episodes before.
2 episodes before,
Right.
when we did space and all that,
Yeah.
and we mentioned the Webb Telescope.
Yeah. So
That on its own should have its own.
yeah,
Yep.
so this is like
Podcast.
part 2 to that. We're going to
Yeah,
talk more
'cause-
about the telescope, you know.
The way this thing is,
Yeah,
how
yeah,
it
yeah,
works
Yep.
is amazing.
Cool.
You know,
It is a
It
very
is.
amazing telescope.
it's been finding a lot of stuff that we thought it contradicts everything. A lot of things they're saying now. Like when
Right.
they find certain things, they go, "Wait a minute, we thought it was this," and then it turns out it's something else.
Right.
I mean,
Because he's that far back. You know,
it's insane.
it orbits around the sun.
Right. Yeah. That's insane, man. That's insane.
and you know, the things that it sees and the clarity of
It's
this,
crazy.
it's insane.
Yeah.
It's like that's what space looks like, because it really redefined what space kind of really looks like.
Right.
Right.
Because when we think of space, we just think of this dark
Right. It's maybe some stars in the
stars.
sky.
Yeah.
But like now you can see like these, like the pillars.
Of creation.
But the pillars of the creation, you always did see those guys, but now you see it, and
Yeah.
it's like
In
it
different
looks
colors. It looks so vivid.
way
So
different than what
wild.
you would think
Yeah, man.
space to look with.
Yeah.
Yes.
The thing we got to forget is we think of rocks in space. We think of little pebbles and things like that. We think of like space debris.
Asteroid belt.
Gases are floating around, and gases sometimes are colors. You know.
Yep. Yeah.
Yes. You know.
It's just magnificent when you look at some of the things that they find, especially now. Like, remember when the Hubble telescope came? That was the big thing, right? And then
Yeah.
they had to change the mirrors because it was wrong. Remember
Right.
that whole
Yeah. They
big
were
thing?
concave the wrong way. And
And they were
such.
out. They had to go in space, and they did it, and they changed the mirrors.
Yep.
And that thing alone found when it took pictures
Right.
and saw as far back as it did, and then you put this thing that goes around the sun, right? And you're like,
Yeah.
what?
You're seeing everything.
Yeah,
bro.
it's
Everything.
amazing.
Yeah.
Formations of stars in I'm not going to read everything that has because there's a lot, but there are certain things we should go. And if there is something, you guys just tell me.
Right.
Ask me. Let's just say this: recent discoveries. The James Webb Space Telescope has recently made groundbreaking discoveries that are reshaping our understanding of the universe.
Right.
Detailed imaging of the Milky Way's core, Webb captured new insights into the dense center of our galaxy, specifically Sagittarius C, like we know where that is, region this year. Located 3,000 light years from the Milky Way supermassive black hole, reveals unprecedented features such as massive region and ionized hydrogens, like you were saying, gas. Then you have challenging galaxies, and there's just so much stuff that you can go on, and how far it's been seeing back now. Like they're saying it's going to be able
To see further than the other telescopes.
Yeah. Right.
but even as far back as the Big Bang, or maybe
Yeah.
they don't,
Right.
because now they want to be able to see what happened before the Big Bang. What was it before the Big Bang?
Right.
That's the whole idea now, right? To try to figure out what's going on. How did that happen? What was it? Of course, we have people who think one way, meaning, you know, that it's biblical or something to that nature. And then you have science, which is where we hang out in that realm, because it makes more sense, you know. And
I have a different theory.
Uh-oh.
I have
don't say aliens, man. You're going to say
Well,
aliens.
yeah, it's
No.
got to be aliens.
little
Yeah.
bangs.
Oh.
What?
Little bangs.
bangs.
A bunch of little bangs.
Bunch of little bangs.
Yeah, poof, 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 poof. Yeah, like, so right here for us with this sun. Then the
sun,
next
yeah.
one out, there's a nux boom. That was another
That-
one.
Yeah.
So
Like-
a bunch of little ones instead of one
Like the
huge
sun
one.
exploded and
Yeah.
spit out, you know, Earth, like, poosh, you know, like little
yeah.
bangs.
Oh,
Yeah.
I see what you're saying.
So each star
Well,
system is like
Have
an
you ever watched the
explosion.
actual
You know what I
thing
mean?
on the like Discovery Channel where they
Yeah,
show you
yeah.
what happened, how the Earth actually formed, and how it
I
works?
just made a mess.
And it's all animated, but you know, digital
Yeah,
animated.
yeah, right.
And they're showing these rocks just
Rocks is
crash
like,
into each other from different
yeah,
places.
right.
And then it's just one big molting rock just burning.
Yeah.
You know, and then from the beginning of time, and then where it goes. So
Right.
it just didn't come from. They're just saying what was before.
But wasn't that part
big
of
black.
what the
That would be cool to figure it out.
but isn't that what pillars of
I think,
creation
like,
came from? Like
nothing,
all the
just total
gases.
void.
Right. So there was like the one thing that it was good, a little bit of a gravitational pull, pulled all the gases together in the rock that was in the area, and then that's what
This
made
is saying different. They're saying because
Really?
they can see far back now, they'll be able
then
to.
now it's
Yeah,
changing
let me-
history or changing what we thought it was.
Well, there's a lot of stuff that it does that.
Yeah.
Yeah, absolutely.
Got it. Yeah, that makes sense.
So yeah, challenging galaxy formations. Theories Webb observations of early galaxies formed with a billion years after the Big Bang show them to be unexpectedly large and bright. This finding conflicts the standard dark matter-based galaxy formation models, but align with the alternative theory called modified Newtonian dynamics. Debate challenges our understanding of cosmic revolution, and the role of dark matter is shaping galaxies. So now dark matter is becoming a big thing now.
Right, because they say dark matter is everything.
Right.
It's in all. It's flowing through us right now.
So the whole time they
It's
didn't even know it
planet Earth.
existed, and then they
And then
realized
they find it, and then
because
boom.
it was right there in front of your face. You just couldn't see it.
You just couldn't see it. Exactly. So that then I know, like I said, watching all the shows and whatnot, that dark matter is that energy. You know what I mean? That's what's kind of keeping all of us going. And now I say keeping us going like that, but you know what? Just makes things happen.
Yeah.
Gives us solids and
Right.
all that other stuff. So yeah,
Let's go.
listen, it's almost insane because every time we
think we
look
have the
out there, we thought we understood it, and it's just like, wow, it's
Right.
something
Nope,
else.
that's
And
wrong.
that's not
This
it.
is what it
Well,
is.
It wasn't
But-
wrong.
no, it wasn't wrong.
complete.
It just wasn't. It still was
It wasn't enough. It wasn't the whole story. It wasn't the whole explanation.
based on the science that they had.
Right.
They came to the most logical
Right,
explanation. But
exactly.
what about the stuff like when you think it's not that they were wrong, they were just off.
Yes.
Or they
Fair
didn't
enough.
imagine that would happen.
Right.
kind
That
of
it
thing.
could happen.
Or right,
Yeah.
or something. Who knows what it is,
Yeah.
right? But think about scientists like Einstein when they look at the equations he has now for certain things, and they go, "He was right,"
Yeah.
and he knew all those years then. Not that he knew, but they said this is what it would most
Right.
likely be,
And he
and
would
this
understood
is,
it.
and then they would look at it now and they go, "On the money." So think of it that way too.
Yeah. Because
That there are people who have already, so they've gotten it right, but didn't know because of based on the technology they had for the time.
right. Exactly.
They could only work so much.
And
what
he
I
was
mean?
ahead of his time. You know what I'm saying?
yeah.
He
He
just all the
wasn't-
things that he was
yeah.
thinking, like,
That could be all-
and Isaac Newton, gravity and what it was and da da da, da, like all that kind of
Those are
stuff.
good cookies. Nah, I hate Newtons.
I don't like them either. No fake Newtons here. Yeah, it's just it's insane that now we have a telescope that can see exactly what it was, exactly how it's happening.
Right.
We can't say in real time because it's so far away that we can't see it moving like that or doing whatever. But that now we're seeing it. It almost. I wonder if I haven't read all of it, but now if that's how they're gonna find where there are planets that we'd be able to live on, or like planets to have some kind of life forms on them. You know what I mean? I mean, they found a couple that, yes, that looks like it's going to be this. There's like 3 Earths, what they call like Earth 1, 2, and 3 kind of thing.
Yeah.
And they all look like they can. But
How
to
do we know
see,
that? How do we know not there's other people
That's
living
it.
there?
So listen
That's
to
what it
this.
is.
Listen to
Yeah,
this. Distant
exactly.
We're
galaxies
gonna
and
try
early.
to pull some, colonization crap.
yes, let's go. Not here. Not in my neighborhood.
Well, check this out. So distant galaxies and early universe. So you're saying, right? So telescope has observed some of the earliest and most distant galaxies dating back to about 200 million years after the Big Bang. The observations are reshaping the understanding of the universe formation and early growth.
Right.
So already the telescope is saying, yeah, sorry, this is what it is. And they're like, okay.
Yeah.
But they're not upset. That's the great thing about science, though, because even though you may have thought one thing, or they did, and a lot of times they usually get fucking right, or they're in the right
Right. In
the right area.
Yes,
You know what I mean?
Right. Exactly.
But didn't imagine that it could do this or that or whatever it is. It's never that, oh, it was wrong, we got it wrong. No,
Yeah,
oh
nope.
shit,
Yeah.
it was wrong, but
Yeah.
look what we got now, kind of thing.
Yeah,
Like,
yeah.
like what we just learned and we figured out. And now they have to figure out why they didn't think about it or think about just how science works, so there's always work. It makes logic
Yeah.
to just try to get the right answer,
Well, even here now, they're starting to find artifacts that are that are older than we thought. You know, so like we thinking that civilizations now on this planet were, 100,000 years old. Come to find out they were 300,000 years old. You know, a lot of things that they're finding in all these, new caves and stuff that, are popping up kind of thing. It's like, whoa, whoa, And I will say, I'm surprised that we're not catching, a little bit off the subject, I guess, but that we're not getting more, because, some people believe in UFOs, that we're not seeing more activity in the distance. You know what I'm saying?
Who's to say we're not? Who's to say that they're getting it and they're not telling it? They're not going to
telling
go,
us.
hey, by the way, did you see what the web caught the other day?
Yeah,
we're not going to put that one out.
They say, they don't know if it's from either the use of social media, but there are more reports of
unidentified flying
UAP sightings.
There's also where they say that the actual astronauts who were in space back in the day when they first started had actually observed certain things,
but they never talked about them because they knew
they never they couldn't put that out, right?
Well, that's the same thing like in the movies. If we go for the movies, Transformers, the Dark Side of the Moon, it was that there was activity on the other side of the moon that we don't see. And that's why the astronauts went up there and landed on the moon so that this way they could see what was on that side.
You mean in the movie?
In the movie, yeah. But then it was in the movie, but before the movie came out, it was something that was spoken on.
Right, yeah. But they talk about it. I mean, they haven't, I don't know if they've gotten to the dark side or if they've had probes go to the dark side. And I think they have. Where they were able to, see what's on the other side of the moon.
Right,
obviously.
and that's what I'm saying. So then that's what I'm saying. I wonder what the telescope has seen just on our moon alone.
Right. Well, let's see how it works.
Other moons
let's see how it works first of all, right? So the James Webb Telescope works by using cutting-edge technology to observe the universe in infrared wavelengths. Here are a breakdown on how it operates. Infrared observations. Unlike the light telescopes, the Hubble Webb focuses on infrared light, which can penetrate gas and dust clouds, revealing objects otherwise hidden. Infrared also allows Webb to observe extreme distant galaxies by capturing the light and stretched to longer wavelengths by the universe's expansion.
Yeah,
pretty crazy stuff.
See? Yeah, that's why it's so cool, man. Like I said, just to see. I've only seen a few of the pictures that it's sent back. It's insane. It really is. Insane. And then it's so far away, it makes it.
Well, think about it. It's going around the sun, right? So it's got a sun shield. They're talking about it right here, which protects it. So sun shield, a 5-layer sun shield, roughly the size of a tennis court, protects Webb's instruments from solar heat and keeps them cool at 233 degrees Celsius. Negative 388 Fahrenheit, essentially for infrared observations. So and obviously they got the sun behind it, right?
Yeah, so that's so cute. That's the big thing. Yeah,
I mean,
the sun behind it.
That thing's taking some crazy ass pictures and going far back.
Yeah, and then because of where it is around the sun, it's getting it's getting a better picture.
It's like, think about having a backlight.
Right, yes, exactly. I mean? Yeah, it's a backlight.
The brightest backlight you can have in the solar system.
Yes, it is. It's the truth, man. It is. It is so crazy, man. And I would like to see.
Well, it's like having the sun outside as your backlight.
Yeah, dude, yeah, and you get good pictures
towards everything. Right. Yeah,
I want to know what Pluto looks like.
Now they got pictures. You got to see the pictures.
That's what I'm saying. Because they said it was smaller. Remember, it wasn't a planet, and then they get back. It was a planet again.
It's all water, and it's crazy.
See, so
it's nuts.
It's wild, Well, I think everything.
But that's what I'm saying. It's like, not to cut you off, but when they were able to look through just normal telescopes from what they had, and then it go bigger than that, and it got bigger than that. And then it just kept progressing and getting better and better and better. So again, with science,
and then you had the Hubble, which
just an improvement, right? And that was just like the granddaddy of all of them. You know what I mean?
But then this blew that out of the water.
Yeah,
bro.
And the Hubble was the launching for the one that they did, right? Think about it. They said, "Oh wow, the next one.
Yeah,
what if we had it orbiting around the sun?
Right?
What?
Yeah, boom. There it is.
Yeah, here we go.
And I mean, there was one that they sent out. It wasn't even like a telescope. It was just a camera, and that's the one that they shot out that is already past Pluto. It was out Pluto a couple of years ago, whatever. And the pictures that thing was sending back, that was wild too. Going away from the sun. Like you said, again, the sun is the backlight, and I would love to see the actual coming together of all the gases and the rock and whatnot, like around the black hole. Like I want to see those pictures. I didn't see any of those pictures or looking up this telescope, but just to see them like that last, just boom.
Well, you get those star clusters. When they show pictures of those star clusters,
right?
They actually give birth to stars that are just coming out.
Yeah.
It's just like it's crazy. You're looking at it, and the Hubble took pictures of them, and they were magnificent when you looked at them. Right? You're like, wow, look at these things. Look at the colors, everything. Right? It looked like something from a sci-fi movie.
Yeah.
And then this thing takes pictures of the same picture, the same place, and it's like, what?
Yeah, you could see the differences now too. From the first one, you could see like some of the pillars are are different. They're different shapes or whatever. It's a lot fuller, if you will. Bro, it's so crazy, so crazy. As I said, I would like to see the live pictures. I wish we could see the live pictures if there was a such thing. Just to because you're gonna see shit flying out there.
How come it doesn't have video cameras?
That's what I'm saying.
Yeah, why don't it have video?
It probably
video would
does.
look so awesome.
But it probably does, but we can't see because so now when the astronauts
L2
are
is
orbiting,
gravitational stable.
They have a 10-second delay on the video that we get to see because if anything happens, they don't want to see it. So because so many UFO stuff, that's their buffer. Or if anything's happening, they'll get that 10 seconds.
No video.
Exactly.
That's
so
why
there's video.
All right, now that's gonna further my reasoning. For,
Right. Well, there's video.
UFOs.
We just don't get to see the
Well, check
video.
it out. This is how far it is from. So it's Lagrange point 2 L2 orbit is what it's called. A gravitational stable point located about 1.5 million kilometers. I'm sorry, miles away from Earth on the opposite side of the sun.
Okay. I
So
thought it orbited the sun.
it does.
Okay.
What does the telescope?
Yeah, it orbits the sun, so then it catches
It does
us.
orbit the sun, not the Earth, at the specific point known as Lagrange point 2.
Got it.
There's how it works.
It's taken some pretty cool photos of the.
It's
of
so
the Earth.
interesting.
Yeah, that's what I'm saying, bro. It's so
Combined
great.
with orbital motion and the telescope create balance that allows the Webb to maintain relatively stable positions relative to Earth and the sun.
Yeah,
It's good stuff, man.
yeah. That's why it's got to be cool, man.
I think what's going to be nice is that when we kind of figure out, and they're going to find out eventually because they're getting closer and closer, how did it all start? And then everybody's going to have their own thing about what they think was it or started or how or what's about why, But we might be around for that, fellas.
Listen,
We might be around for that because this telescope is no joke. They haven't even made a dent with this thing yet. Think about it. Were they only? How old is the telescope right now? Maybe 2 years.
Yeah, I think it's 2-3 years. It went up just before 2020, wasn't it? So it might be a little bit older than that. I thought it did 2020, like 18 or 19. It went up,
Right.
and then we started getting the pictures around there, I think. But yeah, man,
It's 3 years old.
3 years old. Sorry.
Yep, 3 years old. Pretty cool. As a Nova 24 telescope is approximately 3 years old. The mission is designed to last at least 10 years, but thanks to precise fuel usage and efficient operation, it could remain functional for 20 years or more.
Yeah, that's the same thing with the Mars rovers. They sent down the 2 rovers, and
One
they were
did
still
die
going.
on them, though.
Yeah, eventually.
Yeah.
But then, so one died.
It's beat to shit,
so it was
too.
the 2 of them. One died, and then there was this crazy wind that came, cleaned off the solar panels. It charged up again, and they were able to use it. So it's one of those things. But dude, listen, man, I believe our technology now is better than what we're being told, because I think they just know a lot more than what they're telling us. In all honesty, you know what I mean? I think that they know a lot more. Not so much about aliens and stuff, but they just know more. They see more. They know what our future's going to be. Whether it's that they're like, oh, the sun's going to stay lit up for like 10 million more years.
Just so super just to know, period. Just the imagination alone, because when you look at when they have like a diagram or something, and they go as far back as what they're seeing now, and then what's after that? Like, where's the end to what we're looking at? You know what I mean?
Right.
Yeah, that's what I'm saying. Just to know, to see it,
And
you
then-
know, it's wild. Everything that we thought as far as time was concerned is a little off. It's just that much
well,
off.
they're starting to get right. They're starting to see things differently now because of the way things are.
Yeah.
Yeah.
You know, technology now can do things that it's never been able to do before, which is fantastic.
Yeah.
Which I love.
I wish we could travel faster. Like we can get cameras or whatever, satellites and stuff to travel faster and the information come back faster. You know what I mean?
Well, they're working on that too.
Yeah, that's what
They're
I'm
actually
that's what
working
I'm-
on a warp engine.
I wonder
That's what I'm talking about.
They're working on one with her.
if they could figure out something with dark matter, being able to as like a propulsion
I
system.
think there's something about that
There
as
is.
well.
So there's a
One
spot
should-
out west, and they have a tunnel. It's in a big ass circle.
Yeah.
It's like couple of miles round, and they're trying to crash the atoms. So that this way they can get to make dark matter, trying to make them explode.
Yeah.
The problem is that if they really do hit, that it could make a black hole.
Yeah, but maybe they shouldn't do that.
That's what the combo has been. Like, well, maybe we shouldn't do this. They're like, well, no, we're trying to keep it in. It's under this, and then I'm like,
Would it be a full size black hole? Or would it be like a miniature
no,
black hole?
but that's
It
the whole
only
thing.
sucks things.
All it takes
like-
is a little one. It would start with a little one, and then it was.
Oh, you mean if they create one, you mean?
Right? Yeah, they create one that it could just grow.
They already have,
Oh yeah, why Why
Organically.
are we doing that?
in a sense, where they use water or different material, but they're not trying to do it where they're actually trying to open up something. You know what I mean?
Yeah.
Can we make one and see how it works and get the idea of how it does?
Yeah.
Yeah,
So
let's
basically,
not-
it does
let's
pull
let's not
in.
do that.
It does pull in, gases and space rock and everything like that. It pulls whatever's around them. It's going to suck it up. It's like a big vacuum.
Certain
Yeah.
things we just shouldn't
Yeah,
be doing.
but
No.
the idea is what it can do for us as far as propulsion. Like if that's going to be something that's worthwhile
Yeah.
for these things, that's what they're looking at,
Creating a
bro.
black hole,
Yeah.
or like amazing
Destroying us.
propulsion
Yeah.
system.
How fast can we go? I don't
Well, maybe
know.
the James Webb will be able to
Yeah, well,
somehow
that
explain
propulsion
how
system better get us
space.
the hell out. You know what I mean?
Yeah, no shit. I'm sorry, Lou. Say again.
Maybe the telescope will be able to explain that
But that's I want to
by
see
certain
how
things
it
that it
starts.
sees, and
Right.
you might be able to,
To see how a black hole starts. So we already know what it looks like.
or
'cause
how
there's
old it
pictures
was
of
and when it, and we're looking at it now.
Right.
Because when you see it, you're looking at it.
So we
Right.
got to see how much it's grown. So that then the video that they probably already have, they know that it's grown to yada yada size, pictures of it or whatever else. And the matter of fact, this telescope has actually helped us see how they work, if you will, to see all the things that were orbiting it and how fast it came in. And then it's like that flash of light because it's gone, because like doof, it's just blowing up as it's getting in there. So they say there's one just outside our solar system.
What?
There's
black
one in
hole.
our in the Milky Way.
Yeah, see. So yeah, it's kind of cool to see.
There's black
Scared
holes
as hell.
everywhere.
Right.
They're finding out there's
do they keep
everywhere, and-
growing? Is that what the thing is? They keep growing, or
They can,
Yeah, they can. That's what we're saying.
The more-
They're finding.
and they
they're
get
starting to
super
find out.
hot. They can get
Right.
super hot, man.
There's so what it is that because of the gravitational pull
But you
that they
need them.
have,
They're
in
trying
them
to find. They're
spinning.
finding out now that they think that it's necessary that they're there because that's what helps keep
maybe the balance
the universe.
Wasn't there a theory that like a star turns into a black hole?
when a sun.
When a sun, well, a
Right,
star,
star, yeah, right.
A star, a sun.
Yeah, but they're finding so
and
many
then-
now. It doesn't even
And
matter.
then the black hole turns back into a star,
So
and it's just going it burn out.
so it's the
burst,
sun.
yeah.
It's the sun. It's that it dies when the star
Yeah.
dies. That it implodes.
and then
And that
it sucks
gravitation
everything in, and then
and
it
it's like
explodes again.
right, and then when it explodes, that's what creates the black hole. It's that energy that makes the black hole. So then it's not that it comes back and turn into a sun again. It's like what they call like a supernova.
Yeah.
And
Check it
that's-
out. Space supermassive black holes in the early universe. JWST identified extremely red quasars, which are supermassive black holes surrounded by dense gas and dust, dating back to when the universe was less than 700 million years old. These quasars were detected through gravitational lensing, which amplified the light and revealed their extraordinary brightness caused by intense energy released during matter accretion.
Right.
Right.
So
See? So that's what you see.
this thing is finding that now
Yeah. So you get to
When it-
see it.
when it was in its infancy.
Right.
Yeah.
So then now I want to know what it would look like. I mean, like you said, a few million years ago to, like what it is now to, see how much it's grown or shrunk or whatever. You know what I mean?
Yeah.
That's my question.
What is a quasar? This quasar, powered by a black hole with a mass of about 1 billion suns, was found to derive powerful quasar winds. These winds, traveling at 4.7 million miles per hour, are capable of ejecting massive amounts of gas and dust, potentially halting star formation in the host galaxy. This discovery sheds light on the early black holes might have regulated galaxy growth. So,
right, exactly.
they're necessary from what they're finding out. They find out, okay, this is what, in order for things to work, we have to have this, and they just move around wherever they do. And you ever see when they show when the galaxies crash?
Yeah.
Into each other?
Yep. Have you seen those?
No.
Oh,
Amazing.
dude, it's freaking great, bro.
They have actual, it took them a long time for it to, but when they knew what was going to happen, they have pictures of it, and you see it, and they just,
and you see them, and it's
and
like,
they just separate.
They go like this, and then when they hit, there's like a, it just kind of like spreads out, and it's just, it looks like almost if you had, if you poured paint on the table, 2 different colors, and you just kind of like see them kind of like,
and then of course they mix up, and then they make, then the galaxies form again.
Yep, they make something else. Yeah, it's insane. It's crazy. Yeah,
it's nuts.
That's what I'm saying.
I love space, man. I was fascinated as a kid, and just the what, not settle on for one thing.
Right. Do they
but
have video
what
of it,
else?
or is it pictures?
It's still.
Oh, you can find pictures, and it'll be video of them.
Of the pictures. It's video of the pictures. Like there's no actual like.
Well, it might. I don't know, but
no, because took too long. It was too long, so like they would have to put all the pictures together. Like when you turn around, you have a flip book. Like when you draw a picture, like.
But it's so cool though when you see it, and they speed it up, and it's like you see them just crash into each other.
Just look it up, galaxies crashing. And it's wild because
we live in a galaxy.
Yeah, we live in a galaxy. Now the other.
So maybe that's how we go, and not necessarily. Well, of course, the Earth could die too, as well.
Right. Well, the Earth could die itself,
in billions of years from now. I mean, we won't matter for us because we won't be here.
They talk about the sun blowing up. The sun was supposed to blow up in 2020. I mean, in 2000. So it's like
we're talking billions of years from now. So.
Well, yeah, we know this now, but I mean, like way back in the day when they were saying that it was it was that it was when they thought the sun was going to blow up because they still hadn't determined what the age of the sun was. So they weren't sure. They were like, because they saw that.
We always learned that in science going to school, man. What are you talking about?
And remember in science that in school, bro, that they had turned around and they said that
never
there was
heard anything like that about 20,000 was going to blow up.
Listen. They were saying that the solar flares were going to have, that the sun was going to, the kind of solar flares that were coming, that it was, that the sun was losing energy, that it wasn't breathing the same. So then they were determining that instead of it being 3 million years from now, that it would die, that it was going to be 1.5 million. It was that it was going to be a shorter lifespan than what we first thought. Now they're saying, no, it's going to be longer. It's going to be
way fucking longer.
Exactly. But
and that's why we have magnetic field, because that's stuff from the sun, and then the magnetic field does its job. So everything has a purpose and a reason for why. Now that they know that.
Yeah. That's
so Tommy's like, I don't care. He doesn't. He doesn't care. He's in this little world right now. I don't give a fuck about no telescope or whatever. Just know.
Yeah. See, this is the other geek moment right here, bro. You got the.
It's like that episode of Chappelle Show.
Yeah, way out.
Sorry,
there,
bro. I couldn't help it.
Yeah, that's great.
I could see the look on your face like you were in another place right now. You were like, nah, I don't hear shit.
That is funny as hell.
ADHD for you.
Yeah.
But that's what's so good about, they keep learning.
Mm-hmm.
Yeah.
And like I said, they either on the spot on the money, or they're in the right area, or then they just find out, no, wow, we were wrong about that.
Right.
We're glad. I mean, we thought it was this, but all right, cool. I'll take that. That's good stuff to know. You know what I mean?
Yeah.
I would think that's how I would look at it.
Hell yeah. Especially out in space, bro. All the shit that's going on out there, like we said.
It just explains, it makes, I think the main idea is just to get the final answer of how it all started and when it began. You know what I mean?
Yeah.
And how, it's a mystery, man.
Yeah.
You know what I'm saying?
Hell yeah.
It's a mystery,
It's like a mystery, man.
That's too funny.
Yeah.
But yeah, bro, it's awesome to see all those things, the pictures that we're getting back, a better understanding of what's out there, because it's going to help us if and when we're around to see the us landing on Mars, or
That's gonna happen.
even going on any of the other moons in the solar system.
When they were talking about the quasars or whatever going faster, was that fast? You said it was like 500 million miles an hour or something,
around the black hole.
Yeah, or is that like faster than the speed of light?
That's crazy fast. Did you see what?
So yeah, it is faster than the speed of light, but I don't know about how much. Like
if that were to happen, it would happen. And it would like crash into our like solar system. It would happen so
You wouldn't
fast.
even know
We wouldn't even know it. We wouldn't even be able to see it coming.
right? No, we wouldn't see it coming, but we would feel the effects.
It would be like
You wouldn't even know. You wouldn't even know what happened.
Yeah, well, I think I think what we wouldn't know happen is when we actually we won't see it coming. I think we'll see the initial pull. Like it'll be that one, like that 5 seconds or that minute or whatever.
I don't know.
We'll see the sun the sun is just like gone, and then you know what I mean. Yeah. I think it'll be that 60 seconds or whatever that we'll have that.
Well, let's talk about how closely we are to space when you think about it, and why we're so fascinated. Right? We have a lot of the same components that space has. So what that space has, we have.
Right.
We're made of.
Right.
So we came from that. You know what I mean? So we're part of the universe.
Right.
yes.
When you think about it, you know what I mean?
Yeah.
Common elements. The most abundant elements in the human body are oxygen, carbon, hydrogen, nitrogen, calcium, phosphorus. These are the same elements found in stars and other cosmic phenomena.
Right.
Yeah.
So,
We're space dust, man.
that's
Yeah.
what we
You're
are.
like
Yo,
space dust, man.
Yeah.
We are space dust, dude.
Yeah.
Literally.
That's fucking hilarious. Yeah, and that's the whole thing. That's why we can't believe, people shouldn't believe that we're the only ones in the universe.
Oh, this just, well, that goes, you know, we did that already. We did that. We'll probably do another one.
What?
On aliens and everything. But that goes without saying. I mean, it just makes sense. It's just the thing is that what they say is it's so far away that by the time the message got to you or whatever, it would be from a time they would already be past that already. You know what I mean?
Yeah, or vice versa.
Be years way ahead in future already before by the time you got it.
Or vice versa, that they're not even there yet. Because think about it, we sent out a record, an actual was the gold record.
Yes.
That had
all the
math
things on
equations on it and music and all that other stuff.
Like,
how to say many ways to say hello.
Who's gonna know what even that fucking record is though? And
hey, that's what I'm saying.
If you're an intelligent, if
right.
you're like, if they have the same intelligence as us and they've never seen a record before,
they would figure it out.
Know what the hell it is.
But I would have to imagine that they would figure it out.
It's a pin. They might try to put it in like a fucking disc player or try to read
but they use a laser.
Yeah. Or even a laser. Yeah, laser disc. But don't
is
forget.
it going to read the same?
But the idea, the thought process and the instructions, if you will, was that they put it in mathematical equations that whatever other life forms that are out there would be able to decipher the mathematical equation that's on it.
Oh, yeah.
To then that they'll know how to do it.
Universal
right, because math is universal.
Exactly.
That's
you
what
take, adding and subtracting.
You got 3 eggs plus 2 eggs.
Yeah.
Yep. So they put that on there.
3 space eggs plus 2 space eggs.
Yeah, you get Godzilla. Right. Yeah.
Exactly. You got 5 gray aliens, and you take away 2 gray aliens.
Oh, they were racist over there on that planet. Yeah, gray aliens. Oh yeah.
Yeah.
What are you trying to say? But that's the whole thing. Even for us, we always, well, not always, I'm lying, exaggerating. They've said that we have heard space noise.
Right.
So
I love when they do that.
Right. So now the space noise.
You ever listen to that?
So the space noise is like,
guys
what's the space
know more
noise?
about this? I don't know.
Yeah.
They have actual recordings of what space, space, whether the probes or whatever they have, the satellites, and they're able to hear and just record what it sounds like in space.
Right.
It's so freaking nuts. It's crazy.
There's no atmosphere. So there not being any atmosphere in space, in the darkness, how is that sound getting to us?
Yeah.
That's what the question is. So
but depends on depends on where the satellite is. It's what he's picking up where it's at. So he's getting all that noise, and we're getting the recording of whatever he's sending back.
Doesn't sound need to travel through air.
But that's what I'm saying.
It doesn't necessarily have to travel through air. No.
Wow. Okay. Well, so it's traveling through the gases. My point is that how far off were those sounds when it was being made?
Because even when you watch the
But no, these are ordinary noises just of
no.
of rocks and stuff and things, like your
when you watch the rockets take off into space, right?
Right.
In the videos,
Yeah.
Right.
Because you're inside the spaceship.
yeah, but
so you're
as
hearing
soon
the
as it
vibrations.
leaves as soon as it leaves
Right,
the
yeah.
atmosphere, no sound, right?
Yeah.
No oxygen.
But you notice
there.
that the fire still works. It's propulsion, so they're still going.
Yeah.
No, but what I'm saying is there's no sound because there's no
Or the
air
engines,
to
I should
produce
say, the
the
fire
sound,
coming out of
is
the
what I'm
engines.
saying. You know what I
Yeah.
mean? There's no air to produce the sound.
Right. I get it.
So that's why. Where does the sound come from?
Well, with a sound, like I said, inside of the
Something's
spaceship,
making noise.
Yeah.
you get to hear it.
But they say it's from all the gases and the things that are going on, or depending on what area they're in, But can you imagine that? That's good stuff.
Yeah. I want to know where it's coming from.
Yeah.
I'd like to know, like I said, where that sound is coming from.
Yeah.
Is it just the other galaxies that things were crashing, things that we're seeing now, but the sound got here first. So we don't even know. We got to sync it so we can hear it. So no, there is no sound in space because sound waves need a medium to travel through, like air or water. And space is a vacuum with almost no matter, says Google. So now, again, they have to travel then, if we're getting any sound or whatever it's bouncing off of, would be through the gases that we are seeing through the telescope that are coming, that are flying through the...
So I have Voyager 1 and 2 sounds. As the Voyager spacecraft traveled through space, they recorded electromagnetic signals from planets, suns, cosmic rays. These sounds are often converted into frequencies with human hearing range. For example, the sound of Jupiter's magnetic sphere and Saturn's rings have transformed into audible frequencies.
See? So that then you need to have something for it to
NASA
travel
space
on,
sounds, collective space recordings, including the eerie sounds of the solar wind and magnetic fields around the planets. These recordings are typically generated by instruments like the plasma wave instrument on spacecraft, which detects fluctuations in electric magnetic fields. Pretty interesting stuff.
Right. Yeah. See? So that's why it'd be cool to know where it is, because then if it's not that far out in space, it's bounced. Something out there is making it.
Sound travels just like anything else, just like light. It may not travel as fast.
Yeah.
Right? The speed of light is faster than the speed of sound. So obviously it's going to travel for however until it gets to you, depending on where it's coming from.
And that's the whole thing.
But you could be in a spot where all that's going on already if they have the satellite going through and he's recording. And it's
that's
recording.
What I'm saying. So where it is that it's coming from, we already know that matter moves through and gases are moving through space already. So that then if we're catching something from where, let's say if it's moving, left to right when we're looking out into space, that then where did that gas come from? Yeah. That's now carrying that sound,
Oh, check this out. Interstellar sound. The cosmic of microwave background radiation, the afterglow of the Big Bang, has also been converted into sound waves. These provide the background hum of the universe itself.
Yep.
That's deep, man.
Yeah, way deep.
That's good stuff.
Yeah. Far out.
Far out, man.
That's great. Yeah. That is great.
Yeah, super far.
Yeah. Again, it'd be cool if there is some. Now here's the other funny. It went out there. That record went out in a satellite a long time ago. So now, where did it land?
It went out when I was a kid.
Yeah. So now
maybe it went before. I don't even know.
So when it went out there, who's gonna catch it to turn around and think to even look and see? They would have to put the record back together if it crashed and hit a planet or whatever.
I think it's just still traveling.
Yeah. I mean,
I guess I think someone's
unless
gonna,
it crashed
grab
into
it
something.
Space.
Yeah, like it's gonna,
if it crashes into a planet,
could you imagine seeing that going by? You're in a spaceship, you're in your thing, hanging out. Like, what the fuck?
Who the hell is littering out here? What the hell?
It's got to be Earth.
Yeah. It's got to be those guys over there. Well, no, they don't even know we're existing yet. I bet.
I'm just saying.
You
never know. They have people who travel. If you have people travel, they know what planet it came from.
The Klingons.
They're smarter than us.
Like the meme that says that's why the aliens don't talk to us.
Yeah.
Exactly. They're idiots. Don't even go there yet. They haven't reached that point yet. They're not there yet.
Yeah. It's just so amazing, to think that between the telescope, the things that we've seen on television, documentaries and stuff, we are where we are in our thought process. Now it's, oh, wow, yo, this could be, that could be. So many things have come in these last 75 years, we'll say, that now even things like Star Trek looks like it could be real.
Yeah.
Star Trek more than Star Wars, but, Star Wars was probably what's already going on the other side of the, of the universe that we're not even seeing, It's
right. To go back into time and see what it looked like when it first happened.
Yeah.
Again, the thing is we don't know what's actually there. We're seeing the past.
Right.
If we're seeing 100 million light years away, that's 100 million years ago.
Right.
We're seeing.
Right.
So there could be entire civilizations.
Oh, by now, it's just
like even for them, they see us.
We can't see real time.
Yeah, they looked at us from when we were in 1965, and here we are in 2024, or probably even longer than that, depending on where they were or whatever else. Because again, with the aliens, they say that they come from Orion's belt. And that's far, far away. Right. So then now, that's why, like what Tom was saying before, I want to know what they see over there in Orion's belt.
The way the travel, you have to be realistic as far as that goes. It would have to be some way that they've been in space, like a warp engine. Like
right,
trying
the
to
warp
figure out
engine.
where they're figuring out where they're able to just... They'll be able to move faster because they won't be going... It'll be pushing space out of the way for them.
Right.
Yeah.
Yep.
You know what I mean? It'll be like, there's no friction or any type of thing, and you would just be, or some kind of portal where you open a window, or where they're able to jump from one place,
bend time and space,
and then go to another time where they just pop in and out, something like that. Who knows? I mean, it's possible, right? Think about it.
And that's what
I don't know. I mean, because it goes our imaginations. That's the kid in us, and
Well, they said
it couldn't be far off because a lot of sci-fi came true, man.
Yeah,
a lot of sci-fi came true.
Well, I forget where I saw this when they were trying to explain how like teleportation would work, or like it's like if you want to get from point A to point B on a piece of paper,
you have to fold space.
Right.
You'd have to fold space.
Exactly.
Right.
So then we have to fold space, like you just said before.
I remember reading something on that. Yeah, it's pretty cool.
And it's way groovy. So that then, even with that still, what if that the aliens that we hear, the grays, the whites, the tall grays or whatever, it's that they getting here because it took them so long, that this is their quote unquote evolution.
Yeah, but if they're already they damaged their ship and they just couldn't get back or whatever. And they didn't have the technology at their hands to be able to go back.
They can't fix it or whatever. But then
I would think if they're that far advanced, they're probably already bending space and doing all that.
Right, but it took so long. Even still with the bending of space, it still takes that long. Like I said,
we'll find out.
There's
man.
TVs and shows and stuff where they show where people that live in space for an extended amount of time, or just that they live on another planet where there's less gravity.
Right.
They look differently.
Well, we'll find out, man.
Yeah.
If not in this life, the next.
Yeah. I'm going to stay here until that happens.
Yeah.
Just saying. What's a shot? All right. So with that, everybody, thank you for listening. Love, peace, and hair grease.
Live long and prosper.
And go vegan.
Yeah. Holla.